All right, welcome back. Now let's take a look at solving rational equations and inequalities. Now I'm sure you didn't have the time to do all of the equations, but did you notice that there were some with extraneous answers? Maybe we should take a moment and talk about the ones that have extraneous solutions. When would you find it, and what does that mean in the problem? So let's take a look at another example now of just dealing with a rational equation. Something like this. I want to solve 2x over x minus 1. Here we've got a domain restriction, an answer we can't have. Over 1 plus 1 over x minus 3, and here's another one we can pick up, equals 2 over x squared minus 4x plus 3. So it should jump out at us that we've got domain restrictions, that x is not allowed to equal 1 and x is not allowed to equal 3. And then what would make this equal 0 as well? Well, if we factor that, and we're going to need to factor it anyway to solve the problem, we would have 2x over x minus 1 plus 1 over x minus 3 equals 2 over, and of course, two things that multiply together to give me positive 3 add up to give me negative 4, x minus 1, x minus 3, the same as the denominators over here. So there's no new restrictions over here. I still have the restrictions that x cannot equal 1 and cannot equal 3. Now to solve this equation, we could graph this in y1 and graph that in y2, but I want to solve this algebraically. This could be a question on the non-calculator part of the test. First thing I'm going to do is I'm going to make all the denominators go away, make this equation a lot easier to deal with. I'm going to multiply the whole equation by the denominators, x minus 1 and x minus 3. So I'm going to multiply it in to all of the terms. When I multiply this times the x minus 1, the x minus 1's cancel, and I'm going to get left with 2x times x minus 3. Plus, the x minus 3's will cancel here, and I'm going to have 1 times x minus 1 equals, the x minus 1's will cancel, and the x minus 3's will cancel over here, and I will have just 2 left over. So now all of a sudden this becomes a very easy equation to solve. Very nice and easy equation. This was tough. This is college algebra level here. This is algebra 2 level. If I distribute, I'm going to get 2x squared minus 6x plus x minus 1 equals 2. I'm going to subtract the 2, combine like terms. I get 2x squared minus 5x minus 3 equals 0. This is going to factor very nicely here. And I'm going to get 2x, let's see, 1, 2, I'm going to get 2x plus 1 and x minus 3. Let's see, will that give me 2x squared and a negative 3, negative 6x and a positive x gives me the perfect. And then set each factor, let me scoot it up here a little bit, set each factor equal to 0 and solve. 2x plus 1 equals 0, x minus 3 equals 0, subtract 1, divide by 2, x equals 1/2, add 3, x equals 3. Here are my two solutions that I'm getting. And of course, hopefully you're looking at this saying, wait a minute, we've got the restriction up here, x cannot equal 3. This is an extraneous solution. It is a solution that does not work. So on a test, if you did all this work and you didn't eliminate the extraneous solutions, you would lose points. You've got to recognize that that solution does not actually work. All right, so now let's take a look at inequalities, solving inequalities. We know what the symbols are. So a rational inequality might look something like this, where I've got a p of x over an h of x, and it's going to be greater than 0 or less than 0, or greater than or equal to 0, less than or equal to 0. And of course, when we're talking about just greater than or equal to, that's going to affect what type of braces we use in our interval notation. Do we include the point or do we not include the point? So when we're solving these, and we can do these graphically, we can plug this in to y1 and see, well, where is it greater than 0? Solve for the zeros or the roots or the x-intercepts to find the intervals. And then, well, where is it above the axis? Where is it below the axis? Let's take a look at one and talk about it algebraically, one that we might see on the non-calculator part of a test. For example, suppose I want to solve x minus 2 over x plus 4. Where is that greater than 0? Well, as I take a look at my critical values here, where are interesting things happening? Well, when x is equal to negative 4 and when x is equal to 2. Those are my critical values here. So what's happening when it's less than negative 4? What's happening between negative 4 and 2? What's happening after 2? So my intervals that I'm curious about are from negative infinity to negative 4, negative 4 to 2, and then 2 to positive infinity. And I want to see, well, what's happening over each one of these intervals here? As I pick a test value in this interval, pick, for example, negative 5. And if I plug negative 5 in here, negative 5 minus 2 is a negative number. Negative 5 plus 4 is a negative. Negative over a negative. It's going to be positive in this interval. This expression will be positive in that interval. If I pick a value here, a convenient value would be 0. And I get negative 2 over 4, which is a negative over a positive. It's going to be negative in that interval. In this interval between 2 and infinity, pick something like 10. 10 minus 2 is a positive. 10 plus positive. Positive over a positive is positive. So I want to know, where is this expression greater than 0? When is it going to be positive? In this interval and that interval. So my final answer, I'm going to have in here and here. So my final answer is going to be from negative infinity to negative 4, and then again from 2 to infinity. Now, if this had been or equal to, greater than or equal to, I would change these to brackets, because at negative 4, it's not even defined. Well, actually, I couldn't put a bracket here for negative 4, but at 2 I could. It is defined at 2. It's 0 at 2. So if this had been greater than, this would still say a parenthesis, because at negative 4 it's not defined, but this would have become a bracket. Let's look at one a little bit more harder, a little bit more going on. How about if we want to solve x plus 2 over x squared minus 9. Where is that less than or equal to 0? Now, as I take a look here, what are my critical values in this expression? My critical values of x are occurring at plus and minus 3 and negative 2. If I put them in order from least to the greatest, at negative 3 and positive 3, and at negative 2. Those are my critical values. So what are my intervals? My intervals are going to be from negative infinity to negative 3, from negative 3 to negative 2, from negative 2 to positive 3, and then from 3 to infinity. And I want to explore what's happening to this expression over each of these different intervals. I'm going to pick test values. Here, if I use negative 4, negative 4 plus 2 is a negative number. Negative 4 squared is 16 minus 9 is a positive number. Negative over positive, it's negative in this interval. Negative 3 to negative 2, a little bit more awkward here. I have to pick a value in this interval. If I pick negative 2.5, negative 2.5 gives me a negative number up here. Negative 2.5 squared is going to be less than 9. When I subtract 9, I'm going to get a negative number down there. Negative over negative, it's positive in that interval. Negative 2 to 3, a convenient number would be 0. If I plug in 0, I get positive 2 over negative 9, which is a negative number. It's negative for the test value in that interval. From 3 to infinity, pick some number like 10. 10 plus 2, positive. 100 minus 9, positive. Positive over positive is a positive. Now I want to know where is this thing less than or equal to 0. Now I can never use negative 3 or positive 3 because it's not even defined. But I can use negative 2. Less than or equal to 0, I'm interested in the negative parts. So here's my first interval. So I'm going to do parenthesis negative infinity to negative 3, parenthesis because I cannot include negative 3, and then again from negative 2 to 3. But I can include negative 2. So bracket at negative 2 to 3. So there's my final answer. And again, because it was or equal to, I'm using a bracket there. All right, go ahead and stop the video, and good luck with the homework. Try not to do any of them graphically. Try to do them all algebraically.